Amazing. I think everything's working. Pretty good. Amazing. Cool. Welcome to my first live stream. I hate it when people say welcome to this kind of stuff. I'm just checking right now my audio. So I wanted to talk about a very specific topic. Amazing. I think everything's very good. Okay, cool. So I wanted to talk about a thing that's been coming up on LinkedIn quite recently around whether AI can simulate customers or users. And the basis of this entire hysteria is a paper that has been released on this. It looks like this. So the title is like LLMs reproduce human purchase intent via semantic similarity elicitation of Likert ratings. It's a very wordy title. Essentially what it means is that the paper claims that you can simulate users and customers with AI to a meaningful grade, meaning that you don't have to experiment with them, that you do not have to like go through this really annoying process of asking them and talking to them and so forth. And there's a lot of problematic stuff in there. So it's not that the paper is necessarily wrong. I just wanted to go over and explain why AI in general cannot really predict humans that well when it comes to purchase or anything that they are doing, really. And I think the first thing is I just wanted to basically explain what the paper claims and what it sets out to do. So just really quickly here in the abstract, what it basically says is that that the framework that they are using in the paper is something to prove that scalable consumer research simulations, so replacing your users with synthetic ones, can preserve traditional survey metrics and interpretability, which is not exactly the same as they say in the title, but the experiment looks like this. So what they did is they took 57 real customers, and they conducted them. They conducted a human panel with these people around whether they would buy a specific goods, so consumer products like toothpaste, deodorant, skincare, and so forth. Sorry, it was actually 57 surveys, not customers, of course. So 57 real surveys. This is what they had access to. And then in there was the question about like toothpaste and deodorant, skincare. And they essentially had access to 9,300 real human participants in total because of this, right? And in each survey, what they asked is, how likely are you to buy this product on a 9 to 5 scale? So this was the question that they asked. So like, how likely are you to buy this product on a 1 to 5 scale? And this is called a Likert rating. Likert ratings go from 1 to 5 in absolute numbers. And they showed the same concept to an LLM. So these were the surveys that they used. In there were 9,300 human participants, and they asked the LLM the same kind of question. And what they did is they told this AI what kind of person they would be. So, for example, you are a 35-year-old woman from California with medium income. So they gave the AI context on who it is. And then they basically asked it the same questions that the real people were asked, right? So they took that and they tested 3 different ways in how the AI would perform if it was just simulating these results, and then afterwards they were comparing these results back to what the humans were saying. So you had the human results, and then at the end of this, you also had the the AI results, right? You can already do this by just saying like, by doing this like in your Perplexity or ChatGPT or whatever. In order to do this, they used 3 different methods. The first one was direct Likert rating. Essentially, what that means is they were just asking the AI to choose a number between 1 and 5. The second method was FLR, which is follow-up Likert rating. I'm not going to write this out here. Doesn't matter. So first, the AI writes how it feels. So it seems good, but it is expensive. And then it rates it. Then it rates it from 1 to 5, or they use the third method, and this is the most important one. They used SSR, which is Semantic Similarity Rating. Basically, what that means is the AI gives a short opinion in text, and then it has to match it to example statements. So these example statements would be, for instance, 1, I don't like it, so like I definitely would not buy, and so forth. So I'm just going to copy this over. This is probably faster. So this would be the scale, right? So AI, please give me a short opinion in text. Then tell me which of these numbers are more likely going to apply to this. So when they were looking at the results of this, this is the standard approach that we usually do. Then this direct approach here, so asking the AI to choose a number between 1 and 5, produced relatively bad results. And so what that means is that the results from the AI, without knowing what the humans answered, was not really good. It's just how it is. Probably future models are going to get better than this, but those were essentially the rules. So there were some mediocre results if you ask the AI first, like with the FLR. So tell me how you feel, and then rate it a 1 to 5. So they were a little bit better though. And now the crazy thing that is impressive is that with the SSR method, so doing this extra step before, where it gives a short opinion in text and then it has to match it to sample statements, then the results are really good, which means there's a 90% match between what the actual human said and what the AI was simulating. So essentially, what that means is that this here is the closest to the human results, right? So you had a 90% match between this method of SSR. So what they concluded from this is that if you have such a high kind of match between what the AI simulates and what humans would say, that you could conclude, therefore, that you can simulate consumer behavior. And that's just what that is, right? So maybe just really quickly before I start to go into the study a little bit more and why it's problematic as well, there are some good things about this. So this method of telling an AI first that it should give you an opinion, if it should rate something, and then matching it to a specific scale is pretty good. So there are some advantages to this. So whenever you are trying to kind of figure out something on a scale, like on a Likert scale, like grade my my performance from 1 to 5 or whatever, it seems to be that this is in general just providing really good results. So why is this such a good idea to do this in general? So there are a couple of reasons for this. The first one is that this avoids robotic answers. It's generating in general more diverse answers in general when you are looking at the output of an LLM. So that can be quite good. But what it also does is it avoids the tendency of LLMs to kind of stray into the middle. And what I mean with that is, in general, an AI tends to give answers from the middle. So the number 3 would be overrepresented represented compared to what you would expect humans to answer. So that's a very known problem. You can reduce this by quite a lot by using this SSR method. The second thing is that it keeps the Y. Usually you have this as well with LLM, so they're not just like telling you like, hey, I would rate this a 3 because of, right? Like, so it does this anyways. But in general, you also get a reasoning behind these individual scorings. This can be useful in some cases, but I would be a little bit careful about this. The third thing that we're looking like is it is in general more human-like to think about stuff first in whether you like it before you apply a number. That's just how we tend to think about things. We're not having like, oh, this is a 3, and then I try to match reasons for it. So this is what that is. So if anything, this is a good hack in general to kind of remember when you are producing numbers from AIs, specifically derived from like, you know, opinions and like simulating what someone does and so forth. Exactly. So now, what's not so good about this? And this is the thing where we have to be really careful about, because what they're doing is they're trying to extrapolate what an AI does with these ratings to a very sweeping sort of conclusion on that you can actually simulate users. So why is this not the holy grail that it's supposed to, or like that it says it is? So on one hand, we have a problem that the thing that they tested is a human panel. So a human panel is a panel where people get together to see whether people like something before you start to build it out. And you would do this because you might have a very expensive product. So hardware products are using this quite often, or marketers are trying to get a sense of something, like they're spending a lot of effort into like designing something up before it's actually built. So you're basically asking this question again, right? So like, how likely is it? How likely are you to buy this product? And the problem of this question is pretty big in tech or in software development in general, because there is no real product. The thing that you're testing in this is intent, and intent is something that I think I am going to do in the future. And what we also have at the end of intent is a specific behavior, right? So like, I think I'm going to do something, which is the intent, and then the behavior would be whether I am doing it. And for some reason, people in general are comically bad, customers, consumers, in figuring out what we are going to do. I can tell you whether I like something right now, but whether I'm going to do something in the future, there's a big problem behind, like in between this, right? So, and this is a problem because in general, human panels are only investigating the intent, but they cannot measure the behavior because I'm just asking about someone's opinion. Now, in tech, or like if you're building a website or you're trying to sell a service, what you are doing is you are building something that you can then expose to people, so you can actually figure out of 100 people, this would be an experiment, right? Out of 100 people, how many are doing the goal behavior that I want to see from them, right? And this is a conversion rate that you're going to get. So for instance, out of 100 people that I have, how many of them are starting my trial, are going to go into my freemium, whatever, right? Like something like this. And we're doing this in tech, but this also requires, of course, that you have 100 users. So you might be incentivized to think that, yeah, but isn't it valuable to kind of simulate this entire experience with an AI, because they already showed that it is quite close to human, to how humans behave. The problem is that in these experiments, we are measuring the behavior, because if we just ask for intent, the likelihood of us figuring out what the behavior afterwards is extremely low. So even with this process of us building something, throwing people into it, and then see whether they are actually buying it, right? So like these are not testers or hypothetical users. These are real users that we try to, for instance, convert into real customers. So people that are buying something. Even if we do this superior approach, because this is very close to what we want to do, right? Even with this superior approach, we have a failure rate across tech of over 70% when it comes to predicting whether what we think is going to happen between what is going to happen. And this is in regards to whether something is creating meaningful lift or not. So this means whether an experiment works in the way that I think it does, or whether it just does not meaningfully move the metrics whatsoever. There's a really good book on this. It's called Super Forecasting by Chris Tetlock, that explains this in more detail. But what this means is that most of the ideas that we have, that we are building solutions for and then also experimented around, are going to fail by definition, because experimentation is extremely hard. So this is already quite hard, but going from intent to behavior. So what people say is that, oh yeah, if you build this for me, I'm going to build it, is even harder, because we do not have any proof that it is actually happening. So you would think that you could use this beforehand, before you actually start to experiment around it, but this is not a good way to do it either. I'm gonna show you why specifically afterwards. So this is the difference between intent and action or behavior. That is so difficult to simulate in general. The second thing is that we have very limited coverage. So what this study does is it asks about beauty products and some demographic stuff, like, 35-year-old and whether you're a woman or a man, which does matter for these consumer products. So for a product like this, so a simple consumer product, this might actually work. But if you think about, or like it might work to some degree, I have to be careful a little bit here, but like for a limited data set, that B2B SaaS, so if you have B2B SaaS product or whatever, like any SaaS product, so you're building a website out and you want to have users and you want to do something with it, then you have a lot of problems that are not covered by this approach at all. First of all, if it's a B2B solution, so like a business to business solution, there are so many stakeholders on it. There's a lot of stakeholder complexity, which means there's a buyer, there's someone that's using it, there's someone that's inputting the credit card and so forth. But even if you do not do this, even if it's not just about this complexity in general, what users do, so like real life data on user behavior inside of companies, because you have to understand that what we're talking about here is that someone registers on a page and then they're doing something and then they convert into paid customers, is extremely limited. So we might know how many trials that a company has. Maybe we also know how much traffic that they have on the very top, but everything in between is completely hidden. So an LLM, like a language model, simply does not have access to this data in the public domain, and therefore the synthetic users that it creates from this will be quite stupid. Will not be relevant in a big way. So that's a very, very big problem with this, right? So like the synthetic users will not be a good representation, which means that if an AI tries to simulate anything with it, it's just not going to work unless you're doing something that is extremely popular and widespread. So like beauty products and so forth are not that complex, and it might make sense there to kind of simulate this if you want to replace or do not want to have a human panel. In general, human panels just suck in general, right? Like I've never used them. I think they're complete garbage. In any case, so these are the three kind of main problems. So we have this intent versus action, which is a real big problem. Human panels in general suck, and the third thing here is like this limited data set for this particular thing. Then, so this is just like on this particular study, and why it is really hard to kind of apply this. If you go back to this title and the stuff that we now see on LinkedIn, where they constantly say that, hey, you know, like this is amazing, we can actually simulate people and so forth, then it's really easy to misinterpret this and start to say stuff like, oh, we can simulate our consumers right now before we have to build out our solutions. So therefore, we should change the way that we are A/B testing stuff. Or we should use it to inform or speed up our strategy. Now, this might be a reach, you might think, just like from this title, but I know how founders and CEOs are working in this regard. They are taking stuff like this and then they make quite widespread, you know, assumptions based on this, and they start to act different in a way. And this has been the biggest challenge that I've had when I was consulting with people, or when I'm consulting with people, or like when we're looking at boards in how they look at what's necessary to be done for a company to be successful. The willingness of founders and CEOs and product managers to talk to customers is so low already. Not enough people are doing it. And with stuff like that, you should talk to your customers. And there's a multitude of reasons for this, because AI cannot help you out with this, and AI will not be able to help you out with this by simulating customers. And I want to go into why this is the case a little bit. So this is beyond this entire study. So why is AI such a bad source for customer insights, right? So it is impossible to come up with a good strategy unless it contains something that is hard to detect, unless it contains something that is really hard to detect for your competition, which is a differentiator or an underserved need in a big monetizable market. So in some kind of way, you have to define a strategy that moves your product to a differentiated future. So you're not like, let's say you're producing a car. I always love the Tesla example because everybody kind of understands this. So you're not, if you're building a car, it helps to know, of course, how to build the four wheels, the doors, and all the things that make it a car. This is building out the table stakes. And it's also part of a strategy, of course, right? So like the table stakes are like, what makes my product belong to a specific category, right? And so this can be anything on a car that makes a car, but it's not necessarily what makes a car a good car, or like one car that people would choose over other cars. This stuff is more around differentiators. So like what makes my stuff, special inside of a market? Now, why is this important to differentiate these two? Table stakes are in general the stuff that gets you landed on a comparison sheet. So like I'm in the market for a new car. I'm going to compare 1, 2, 3, and 4. And the differentiators are the things that make you select the specific car. So I have, we are building the fastest, or the cheapest, or we are having the biggest, whatever, right? So it is a very opinionated take on your product. You can have a couple differentiators, of course, that make you stand out versus what the competition is building. So this is getting, those differentiators make you get picked. This is why people decide to spend money on you. So even if I'm in the shop, even if I'm in the process of buying a car, I'm not buying a car because it is a car. I'm buying a specific car because I want to have a good solution that is covering my needs in the best way possible. It's basically just choice, right? Now in tech, specifically, we have more and more and more products that are fulfilling the same kind of table stakes. So differentiation is becoming even more important, of course. And the thing is, when we are thinking about what makes you special, then you have to also think about where does it come from if I want to have a special product. And we're going to go into this in a second. So just really quickly, maybe also on the chat that I've seen. So Joel is saying, computer programming here, I've been trying to make these LLMs work for writing code for ages, and their failure modes are so tricky. Getting value from them is a significant skill. Always seen this lack of intelligence in LLM. Yeah, this is very true. So very good point on this one. Highly recommend that you check out Primetime's video on this. So he's trying right now to get into vibe coding. And there's also really good studies on this that are mirroring on what he says. Aside from very, very simple tasks, as soon as the thing that you're trying to do is going to go over a specific amount of complexity, AI models start to fail for a very, very good reason. And there's very little reason to believe why this is going to change in the future. So models will start to become better, of course, and coding will also be easier with vibe coding to some degree, of course, but there are some concerning factors behind this on why this is not going to get better in the future. I'm going to talk about this in a second, a little bit, Joel. So thanks a lot for the input. It makes you wonder why so many people. Okay, why would people think that LLMs can simulate customers? Well, it is because this stuff here, this is about titles that make really good content on LinkedIn and shorts for videos where people do not have to go beyond the headline, of course, because there is some truth in it, right? So yes, you can simulate people a little bit if the people are represented in the data set and the product as well is well known to the AI. But for most people, if you're working in a company where this is simply just not the case. So who has time to read an entire study? I mean, I read through it and I also saw the methodology. All of it is safe, right? Like it looks like it is very, very good. And the study is not wrong in what it actually tests. The problem is people are not reading past the headline and then they oversimplify. So I will talk about this right now. And this is exactly at the heart of the problem. So I want to really explain quickly on a first principle perspective why this is a big problem. So first of all, you could simplify this by calling leading people towards differentiators in your strategy and what you do in your company as innovation. So innovation, broadly speaking, is I'm going to build something new in a way that has not been done before, and therefore people want to buy, right? And this is not just an optional thing, it is actually a very, very important thing. I'm going to show here really quickly an article of mine. You can also check this out on my Substack. It's called Red Queen Company Death. Basically what it means is at some point, every company that starts to make money has product market fit. And this is expressed in the lifetime value that you get per customer. What that means is you have a product that people really want in a big enough market. This product market fit is going to affect how efficient you can scale your company. So we're producing this particular product, and now we're going to add more developers and more product managers to it. And the better this product market fit is, the cheaper it is to you to do this, right? So this has an effect. This is all of this product market fit is affected by the scaling unit economics, which means the better the product market fit is, the cheaper it is to grow the company bigger with the same methods. More developers, more salespeople, more marketing, and so forth. Your product market fit in itself is then the condition. So once you have this for your go-to-market fit, which means what we have that is big enough is going to be with go-to-market motions. So how do we go into the market and sell it with which message? Is the message understood from the customers? How close is the promise that marketing makes to what the product says and does? And this is then in the end, if there is a good match to this, this is a condition again for your scaling, for your unit economics and so forth, right? So like all of this stuff is connected together. Now, what I'm talking about is when you stop to innovate, your product market fit is starting to degrade, which means your go-to-market fit is starting to fall apart, which means scaling stuff or just upkeeping what you already have is becoming more and more and more expensive. And not just expensive in terms of money, also in terms of personnel. And what that is, it's called the Red Queen effect. This means even if you maintain the same product for a really, really long time, with time, things that make you special become normal in the market, because if you make a lot of money with them, then other people will copy you and so forth. And then it takes all the running you can do. This is a sentence from the Queen from Alice in Wonderland. It takes all the running you can do to stay in the same place. And this is called the Red Queen effect. I'm calling it the Red Queen company death. This is the point where your developers are only busy with dealing with tech debt, upkeeping the product in some kind of way, and they're not capable anymore to innovate at all to get out of this situation. And that's what we call this Red Queen company death. And you can simplify this in a way by saying like this has to do with differentiators. So a good company is coming up with new differentiators all the time. I hope I can convince you that this is an actual, that this concept is actually real in a sense. Exactly. I hope the sound is fine. Like, please also write into the chat if the sound is going to go out and on. Like, I have a noise filter as well. I'm not sure how good it is. It's just it's my first live stream on YouTube. Please just write in the chat if there's a problem. Okay, so let's assume you agree with me and you also see that, okay, innovation needs to happen and this innovation needs to be represented in the company strategy. So, or like how we talk about our product and how we align people in what we do. The only way to find these differentiators, so the data source for them, is in real people. So real prospects, whatever, in your market. And what that means is you need to talk to them, right? So like real life conversations with people. Now, why do you have to have real conversations with people for these differentiators? And why can you not do this with an AI, for instance? Because differentiators have the nasty habit that they are not present in the publicly available data set that an AI has access to, because if it would, then it is very, very likely not a differentiator anymore. Think about it. If you're building something new, then that means it is not overly represented in this particular data set already. The moment it starts to move over here, if everybody knows about it, and it becomes a table stake. And this is obviously a thing that is happening over time. It doesn't always happen. It happens also slowly, and sometimes things are happening in between. But things that we considered to be extremely important for specific products have become just normal for us, and everybody's having them at this point. So, for instance, when Netflix came onto the market and you were able to stream your stuff and you had a recommendation pipeline of, hey, this is the next movie that you should watch, this is what we expect from streaming services nowadays. This is very, very normal. So this has not become this is not a differentiator anymore, but it is now a table stake. So Netflix has to innovate with other stuff, you know, like creating their own series, some other new features and so forth. And it's quite hard for them to also come up with this. And the reason, the second reason why this is only, or like why this is so hard for AI to actually find is if it is easy for you to find these differentiators, so you can just make a prompt about it, then your competition can do the same. Now, why is that a problem? Because that means even if it would be a good differentiator, it's not defensible. I don't want to go too much into detail what that means, but non-defensible means that you cannot like get a lot of money out of it because you're going to be copied very, very fast. This is just the essential problem. This is why these quick or like get rich schemes do not work that people tell you, right? Like all these like, hey, you know, like buy my course, and then if you do this, and then this and this and this works. That's just, it's just a normal, this is just a habit of this particular market that just does not work in this way. And if it's non-defensible, that what means is that it moves very, very fast from a differentiator back to a table stake. So what you want to understand is in your market segment, so like let's say you're producing something for skin doctors in, I don't know, in the United States, is to talk to these skin doctors in a very detailed manner and in detail, and you need to understand what kind of problems that they're facing, so you can come up with a new hypothesis on like, hey, this is a very big problem that we might be able to produce a solution for. And this is why we're talking about prospects here. So prospects are people that might be in the future your customers, but they're not your customers yet. So let me show you what a typical mistake is from founders that they do that is sort of looking like this, but is not really it. And exactly the reason why they're going to also, you know, go into this red queen problem afterwards. So what they do is they plug in their customer database or like customer transcripts. This can be calls from Gong or whatever, or user interviews. So they're plugging this into an AI. Let me just give this a more dramatic color. I think that's quite important here. So this is a, so this would be a suboptimal way. Right. So what they do is they plug their customer transcripts, user interviews into the AI. So this solves one problem, right? Like I said before, that the AI does not have the data set from your market to actually simulate these people. And this is sort of dealing with this a little bit because now you're giving it potential data, because also in these sales calls and user interviews, people are obviously talking about their own individual problems. All right. So this is a new data stream, so to speak. Now, if you're taking this and you go further and you look a little bit exactly into the details, then you see the word customer here. The problem is, what we want to do is to find differentiators in your market. And the differentiator, a differentiator in your market is, out of all the people that are out there, I want to maximize the amount of people that are buying my product, right? Your customers are not a representation of your market. Customers are people that you have convinced with your current solution, with your current marketing, with everything that you're doing, that your product is worth it to be bought. And that's not the same as the market, because at the moment when you were acquiring them, you did not have these new differentiators that you're looking for. So what you're starting to do is you're starting to kind of you're trying to overanalyze your existing data set. So what this means is it's very unlikely that existing customers are telling you about a problem that is really big in the same market where you are usually also are starting to go around, that is worth it for you to go against. There's a very famous story about this in how Twitch came to be. So Twitch originally had a lot of users that, so I think it was called Justin TV. I cannot remember it exactly. So originally Justin TV was a platform about, like what's Justin doing, right? So like just a streaming platform in general, like hey, where you could see what someone was doing. And if you looked at the entire total data set, and also, I don't know whether they were actually monetized back then, but if you were looking at the entire data set, what they had is they had a huge portion. Let me actually paint this a little bit. I want to paint right now. So they had this huge data set of people, right? So those were the users of Twitch. And a huge portion of those was, general people like you and me, and so forth. And then there was a very small segment in there that was gamers. And these gamers were constantly complaining about the features that this entire platform had. So these are general users, whatever. And what they started to notice is that when they were subsegmenting the data on usage and so forth, is that the gamers were asking for specific features like sponsoring, lower latency streaming, higher resolutions, and so forth. All of these things were highly monetizable because there was no platform back then to actually fulfill any of this. So they started to look at these gamers, which were a very, very small kind of segment of the overall users that they have. And then this is what became Twitch nowadays, because they started to kind of pivot the entire platform towards this. Now, why am I saying this? If you go to an AI and you tell it like, hey, these are all my users or all my customers or whatever, please simulate these people, then it's very unlikely that you will see from the simulated behavior stuff coming up that only comes up if you only look at the gamers, because they were very, very vocal about the stuff, right? Like at some point, they decided to, hey, I think we need to talk to these gamers much more in detail, like what's going on and so forth. Because the overall data sample was so poisoned, so to speak, by general users. Twitch would not have existed if they didn't go for this really small data segment of the gamers, started to talk to them, understand what they actually want, and then completely pivot the entire platform towards this. And this is why if you only look into your actual customers and you do not go out to people, why you will not have commercial success as much as you would if you would actually fucking go out and talk to these people in person. It's just not happening, right? So they were talking to gamers afterwards in general, not just the ones that were going on Twitch, and they were starting to do research in like, hey, what are other platforms out there for them and so forth. So there's a little bit more to the story. It's a very, very interesting use case in general, but this is why just plugging in customer transcripts and your own user research is not enough. You really need to go out to prospects, people that could be your customers, but that do not know about you in real life. I would even go as far and say right now, because the building of products has become so easy, the main predictor whether a company is going to be successful in the future as a long-term investment is whether the founders, the CEOs, the leadership teams, and also the product managers are absolutely obsessed with talking to customers in a way that their competition is not doing, because that way you're going to stay ahead of the game. I know it's annoying, like to set up conversations like these, but I really do believe in this. Exactly. So this is what this is, and this goes a little bit now back to the point on what Joel was saying, that leadership teams in general have a tendency to oversimplify stuff, which is natural. I'm also part of leadership teams quite often. We just do not have the context to go into the details all the time. But in this case, when it comes to differentiators, it's extremely important that you do go into the details and that you do talk to the people or someone in your product teams and then comes up with hypotheses. If you have an organization that is very, like autonomous in this sense. So I don't want to spend too much time in like how you actually do this in the right way, but I wanted to touch a little bit like on the future of AI models in this regard. So I don't think that AI will ever get to a point where it can do this in a reliable way for the reasons stated already, but there's also two other factors that I think have come up relatively recently, which I think are indicative of where this is going in the future. So like, even if you ignore all of what I just said, right? Like, hey, differentiators are not in publicly available data and so forth. There's two things that we should consider about this. So first of all, this is maybe more of like a temporary one. This one is called model poisoning. There's been a study by Anthropic that is quite interesting. It's called A Small Number of Samples Can Poison LLMs of Any Size. It's also in the YouTube description. You can also read the paper on this one. Basically, what it means is that you would expect that bigger models, so the bigger the model becomes, the less susceptible it is to bad sources of data. So if you're looking at this here, for instance, what they were testing is they were implementing 250 poisons. So it's called like a denial of service attack for AIs. What it means is there are false documents inside of the data set that the LLM is training on. So 250 poisoned documents, regardless of the size of the model. And the interesting bit here is that you would normally expect that the bigger models are more resilient in picking up the bullshit that is in these documents, and the smaller ones are more susceptible to it. But it's actually not true. So the smaller models here, this is the blue ones. So the higher the curve is, the bigger they are starting to fail with tasks. So the blue ones actually struggled the least. The green one with 2 billion, with a 2 billion model size, which is like about 4 times of what the smaller one is, started to struggle extremely fast when the training progress was observed. So bigger models are actually more susceptible, at least to some degree, when it comes to poisoning. And that's a big problem, because these poisons are objectively verifiable things that are wrong, and then we can check whether the model is performing it correct or not. So if you think about it a little bit further, like let's say you go to 500 poisons, now every model is starting to just behave exactly the same way. So the bigger ones are also not resilient to this in any way. So this is a problem. Now, why is this a problem? Because in this case, when you are testing this, you can check afterwards whether the model is going to give you a bullshit response or not on a fact that is easily verifiable for us in real life. But when it comes to behavior, opinions, political standings, and all this other stuff, where there is nothing to actually check whether it's true or not, I have no idea how you want to figure out whether something is poison or not, right? Like, or like poison in this particular context. So this is problematic because there is no way in reinforcement learning to predict that a model is right now on the wrong path versus the correct path. And especially when it comes to, like, as I said already, like behavior and so forth, this is going to be problematic. So this is maybe like a temporary thing. Maybe we're going to find techniques and also model deployment that is going to go around this. But I highly recommend that you're going to look into this on the on like how they try to verify this. I'm also not an expert, of course, but like really read it through. I think it's a very well written article by Anthropic on this one. So this might be just like a temporary thing, and the second thing, or the second point about this, is that overall data quality, So the quality of data that is around for public language models to actually train on is degrading right now. And there's a fantastic video on this. I'm going to walk you now through just like really quickly on what I'm trying to say, and then you can also like verify whether this is true or not. There's a fantastic video on this from Kurzgesagt, which is dealing with AI slop. So the base hypothesis is that the data that we are using to verify whether a source is genuine is quite often present in the internet, of course, right? So like we have access to studies and other sources. And at the moment, studies themselves, so like these data points that have very high kind of credibility, are starting to get more and more edited by AI. That's not an indicator yet that they're wrong in any way, but like, you know, summarization and letting an AI take control over stuff is obviously also changing these. But further, there is an effect that someone might create content and slop, so to speak, about a less serious topic. So in their video, they're talking about like I think dwarfs, like brown dwarfs in the universe, and why they are a problem or whatever. And at some point, these short form contents become quite popular. So, you know, you have YouTube shorts or like YouTube videos that are starting to become quite popular. They gather a lot of clicks and so forth. And this popularity is then being used by future models that are ingesting these videos or articles that this source is credible. This is how a lot of language models are right now determining whether a source is credible. This might be changing in the future as well or not, but at the moment, it's really, really hard to kind of determine whether content is AI generated, completely AI generated, or whether it is done by humans, by real humans, because there's a lot of incentives in the system to pretend that it is real when it actually isn't. So a false generated hallucination by an AI is becoming a credible source taken up by another AI, which is then leading to, I mean, they're calling it the, sorry, like the death of the internet. And I do agree with this, especially on facts that are very hard to verify, which is usually the case when we're talking about opinions, political opinions, and all that kind of stuff, right? So to me, this is really mind-blowing. This is really mind-blowing. This is a very good video on this. So I think my overall conclusion on this entire stuff here, like on this study as well, is that, look, it's not going to happen anytime soon. It's also not going to happen with the current technology and the way that we think about data and how we think about AI and how it is processing all of this stuff for the aforementioned reasons. I really do not think that we're going to get there. But unfortunately, there will be a lot of people who are believing this. There will be more people who are believing this in the future as well. Not because of this study, but there will be more studies that are claiming the same bullshit. Again, because there is incentive in the system to create content about it, to talk about it, you know, like to make clickbaity titles. And then another AI in the future will also start to pick this up. And then when you ask an AI, for instance, hey, can AI reliably simulate customer behavior so we don't have to build our stuff ourselves? It's going to say yes. Because there's a lot of credible sources out there. For instance, LinkedIn posts with 200,000 impressions, right? Like it will start to cite sources that are probably not that relevant for this. And then someone is going to create a research paper based on all these bullshit claims. And then that research paper is also going to kind of like feed into the entire AI slop. And because we cannot identify the difference of it on Reddit and on other sources, this is going to just like perpetuate this entire kind of mill. It's just shit feeding on other shit. Yeah. Scott Hove is saying, like, I read an Octavio Paz poem recently that got me thinking about how LLMs have only the hollow artifacts of speech and none of the raw human behavior of the present moment. This is such a good point. You know, I was actually thinking about this as well. So I'm an avid Rust player. Not the development language, but like, you know, I play this game Rust quite a lot. And I consume a lot of content on YouTube about Rust. Like how tips on building, like how you should play the game and all that kind of stuff. And I realized that one person or like one streamer or one YouTube account that I really like listening to actually has a very similar voice to a lot of other channels that I'm listening to, and I started to realize that the entire voice is AI generated. I don't mind so much about it because those are really informative videos. But what has happened lately is that also on Instagram, I'm starting to be less and less sure about whether the videos that I'm seeing are actually real. And not just like on important stuff, but like cat videos and other stuff, things that are kind of funny when they're AI generated once and they're completely over the top. But I'm starting to question whether the stuff is real or not. And what was so interesting about it with me is that as soon as I feel like it is fake, I'm not that interested anymore. It does matter a lot whether it is real or not. And now I'm starting to kind of disengage from these channels. Thank God, because Instagram is anyways not that healthy. It's really weird. Just because me knowing that it could be fake is kind of like make me less incentivized to consume it digitally. Because it really does matter whether it's real or not. It really does matter whether this cat was falling off the like the counter, or whether it did some really stupid shit. Because if it's just artificial, then it's like it's not relatable either, right? Like I also have 2 cats and some other stuff. There's a lot of reasons why you want to have a real life experience for this. And I think this is also happening right now with a lot of things that are happening in tech or any of these topics that are just, like pictures and photography. Yeah, it does matter whether you have actually lived through a moment and then took a picture, or whether you can just like pretend about it and just generate this entire slop. It's not so much like whether the quality of the slop is indistinguishable or whether it's the same kind of, the same kind of quality to it. It really does matter whether it's real or not. It's super weird to me, but I'm really over it already in terms of AI. But it's never going to go back to what it was, right? As shitty as it was. Yeah. Words are not signs, they are years. Saying what they say, the names we speak say time. Yeah, that's a good point. So Joel, you said that at some point you think that some of the symbolic and reasoning system may help with these LM issues. So I think at the heart of it, because of how we train AI models, like with reinforcement learning predominantly, so we're kind of trying to kind of like move an LLM towards the correct output by saying like, oh yeah, this is closer to the thing that we want from you. There's a fundamental problem in there. An AI or an LLM is simply not incentivized to say, I do not know about anything that you ask it. And this is why it starts to hallucinate, because saying something, even if it is wrong, is more likely to be right than saying I don't know. So this is a fundamental flaw inside of reinforcement learning. I'm not sure what the research or like what the current state of tech is in this regard. But I think since it's just such a kind of fundamental piece, I'm going to be really excited to see like where it is going. But for the moment, I don't think we're gonna get around this in a meaningful way. There's always going to be hallucinations in these LLM models, especially on things that we actually do care about. And yeah, okay. I hope this was interesting. We're already past the hour. Kat here also wants to say hi. I hope it was useful, and I see you maybe on the next stream. I'm gonna decide whether I'm gonna keep doing this. I also wanted to use this as kind of like a test run, so I appreciate it for everybody who was listening in. And yeah, give me please feedback if this is useful for you or not, because I don't want to produce a podcast all the time and then have it cut by the editors, because I also feel like this is much more real than cutting stuff together, making it really quickly and then animate it and so forth. Maybe I'm starting to get old. Maybe this is what it is. So yeah, let's see what happens. Thank you so much for listening to this, and appreciate you guys for tuning in. See you next time. Bye bye.